Okay, this is your lesson on parabolas in standard form. In this lesson, you will write the equation of parabolas in standard form, identify and calculate the focus and the directrix of a parabola. It's probably a new word for you, directrix. All right, so here's a parabola, and it's one that we're familiar with. It's opening up, and the standard form is this formula that I gave you in class today, and it should be in your notes already. And we don't have a center on a parabola, not like an ellipse or a hyperbola or a circle, but we do have a vertex. H comma k is now my vertex. Okay, that's not the center because there is no center. We have this 4p here. P stands for the distance between the focus and the vertex. Okay, so if you have the vertex here as h comma k, all you have to do is add p and then you'll get the focus. It's really not that bad, all right? And then you subtract p and you'll get where the directrix is. The directrix is a line. And what we really mean by a directrix is that in order to draw a parabola, if you take the same distance from the focus as from the directrix, perpendicular to a directrix line, you're going to put a point, and that point is going to draw that parabola, meaning that this distance here is equal to the same distance from here. Vertical from the directrix straight up, and that distance going to the focus, that is a parabola. This is how they make solar dishes and solar cookers. If you take like an umbrella or some round-shaped object and you line it with foil like the inside of an umbrella, the focus point is where all that light, all that sun heat will be concentrated on. So it's all going to be reflected towards this one spot. That's the focus, and that's why we call it a focus. So you can actually get a pretty hot spot here. You can cook a hot dog or something if you line an umbrella with tinfoil. This is basically the premise of using a magnifying glass and using it to burn stuff with the sun's energy, because it's going to focus all of that light into one spot. All right, and so there's your parabola. In vertex form, this is when you're probably more familiar with. You know that A is going to determine how skinny this is. The bigger the A, the skinnier your parabola. And the smaller the A, the wider that parabola is. But now we have our standard form. If we put the vertex at the origin, that means h and k are 0, then this cleans up really nicely to just this x squared minus 0. Right? X minus 0 squared is equal to 4p times y minus 0. So that's the cleaned up version of that if the vertex is at the origin. Okay, like I said, the p is the distance between the focus and the vertex, and also the distance between the vertex and the directrix. Right. And if we are able to move this to the other side, to the x squared side, like here, the a is on this side now. If you put the 4p on the other side, it'll just be equal to the reciprocal of a. Or if you move the a to the side with the y on it, you can see if you move the a to this side, then the a is 1 over 4p. That's the relationship. If you already know a, you're going to know 4p. So if a is 4, then 4p would be 1 over 4, which means p has to be 1 over 16, because 4 times 16 reduces to 1/4. All right, let's talk about the axis of symmetry. and the directrix and the focus all together on these graphs. Now, we normally see them as going up and down, but now we're going to have them being able to go sideways. When they're sideways, all that means is that y term is squared, and this x term is squared. And the a and the p are going to be negative because it's opening down, or to the left, it's going to be negative. Both of these have a negative a or a negative 4p. All right. So the vertex is here, that's at 2, 1, and this is at 4, 2. The axis symmetry must go through that vertex because that's where it's mirrored on both sides. So as you can see, it goes through the x is equal to 2, and that's the equation. This is the equation of a line. This is the equation of a line, this red dashed line, that's the axis of symmetry. And it's always going to be x is equal to 2 because it's opening up and down. Well, can you tell me what the equation for the axis symmetry for this parabola is? Well, if you think about it going this way, right, that's the axis of symmetry. So that means now y goes to the 2. So y is equal to 2 is the axis of symmetry. This one is x is equal to 2. That's the line, the equation of the line. Y is equal to 2, and this is x is equal to 2. What about the directrix? Well, let's talk about the focus first. Let's say that the focus was here. If the focus was here, that means that p is going to equal 2 because p is the distance between the focus and the vertex. All right. Also, same thing here, and this would be p is equal to 3 on here. Okay. In order to get the directrix, we go on the other side of my vertex, the same distance to my focus, the same p, and we're going to go up. Instead of going down 2, we're going to go up 2. Remember I said that p was going to be a negative number? Yeah, p is negative 2 because we're opening down. And if we go up 2, we're going to draw a line. The line is the directrix. Okay, and it has to go through this point right here. It's going to go 2 up this way. Well, what about the directrix on this parabola? Has to be right here, right? Because since it was 3 back from the vertex, negative 3, now it has to be positive 3 to get to the directrix on this side. Okay, so there's your definition of a directrix, focus, and vertex, how they relate to each other. In the equation of the line of symmetry, axis of symmetry, has to be x is equal to something when it's vertical, which is kind of backwards from what you think of y's are going vertical and x is going horizontal. But if it has to go through the y, it has to be y is equal to something 2. If it goes through the x, it has to be x is equal to something. Okay, let's try an example. Find the standard form of the equation of a parabola with the vertex at the origin and the focus at 0, 4. Well, if you can imagine a point 0, 4 compared to the origin for the vertex, which way is this parabola opening up? Okay, it has to be opening to the right. Okay, this is my standard form, and because it's at the origin, this is h is 0, so now it's x squared. K is 0, so that's just y. And then I'm going to put the origin here, 0, 0, and then the did I say open to the right? I meant opening up because it's 0, 4. Sorry. 0, 4 is up here for the focus. So it has to be opening towards the focus. Alright. So it opens towards the focus. So now, do we have P? Yeah, we have P. P is 4, right? So we know that P is 4, so we'll just put in the 4 into this equation here. This formula, we've got 4 times 4, so that's going to be my standard form. X minus 0 squared is equal to 4p. 4p is 16 because p is 4 times y minus 0. Okay, let's find the focus of a parabola. So we're going to do this, and you should know that need to complete the square, right? Okay, so let's complete the square. When we're first doing this, we want it in standard form. We want it to look like this. And then I want to get rid of those nasty little fractions there, so I'm going to multiply by -2 on everything to get rid of the fraction. So multiply y by -2, I'll get -2y. Multiply by -2 to the -1/2, I get +1. And -2 times -1 is +2, and -2 times 1/2 is just -1. And now I'm going to complete the square. Well, I'm going to move the 1 to the other side. So add 1 to both sides. I'm going to add something over here to make that complete. So half of 2 is what I want, right? Half of 2 squared, so that's 1. Add 1 on each side of my equation. And then I can complete that square here on this side. And 1 plus 1 is 2, minus 2y. And I'm going to factor out a 2 right here. And I'm done. I have it in this form, right? Okay, so I have x minus -1 squared is equal to 4p times y minus 1. So that means my center, or my vertex, I mean, is going to be at -1 comma +1. You see that? -1 comma +1. And my p is going to be 4p is equal to -2, right? This thing is right here is 4p. In solving for p, divide both sides by 4. I get -1/2 reduced. So that means I'm going to go from the vertex and I'm going to go down 1/2. And I know that this is x squared and it's negative, so it's opening down. So from -1 comma 1, I'm going to go down 1/2. So if I go down 1/2, then I'll get -1 comma 1/2. Okay, so if you need to see the picture of that, here's the vertex, -1 comma 1, and I'm going to go down 1/2. If I go down 1/2, that means my focus is right here. Okay, so that means that my focus, for a vertical focus, you can use this little shortcut if you don't want to graph it out. You go h comma k plus p, and that means that k is -1, or I'm sorry, +1 plus a -1/2. -1 plus a +1 plus 1, -1/2 gives me 1/2. Did I say that right? Is 1 plus a -1/2 is 1/2. All right, so that's where that is, -1 comma 1/2. Let's do one more here, similar to one I just did. So I'm looking at this, write that in standard form, multiply by -6 to get rid of this nasty little fraction in the front. So I multiply both sides by -6, I get -6y is equal to that right there. And I'm going to complete the square, so I'm going to move the 2, add 2 to both sides, get rid of that. What am I going to add to the end of that? Half of 4 is 2, and squared, that's add 4 on both sides. And then adding that together, I get 6, factor out a -6, and I get a positive y minus 1, right? Notice that I did a little fancy thing here because I didn't want that y to be negative. So I factor out a negative. So I have my standard form. Once I have my standard form, I know the vertex is going to be at -2 comma 1. And I know that 4p is going to be equal to -6. Solving for p, dividing both sides by 4 and reducing, I get -3/2. So, since x is squared and it's opening down, right, it's vertical, so I'm going to take h comma k plus p. So I'm going to have my vertex at -2 comma 1. It's opening down because this is negative, and I'm going to go down 1.5. 3/2 is 1.5. It's -1 and -1/2, so -1.5. So I'll be at -2 comma -1/2. All right, this is what you'll be doing tomorrow in class, so make sure you understand this because I'm not going to give you any help tomorrow because I won't be there. Okay, use this information provided to write the vertex form of the parabola. So you know what the vertex form is, right? So that's not the standard form. Vertex form is the y is equal to a parentheses x minus h squared plus k. So we're going to scoot that 71 over so I can complete the square. What do I need to put in here to make that work? Half of 16 is 8, and I'm going to add a 64. What do I have to put on the end of that to get rid of that 64? Well, if I want to make that equal to 0, and I'm on the same side, I'm going to put a negative 64. Okay? If you're working with the other side of the equation, you would add a 64 to both sides, but since we're on the same side, we have to put a negative 64. Now we just combine that together, we get a 7, and then this was half, that was 8, right? So this x minus 8 squared plus 7. Okay, here it is in vertex form, that's done. Or if you want to tell me that the vertex is at negative 8 comma 7, okay, and then 4p is equal to 1, so p is equal to 1/4. All right, that's it.